Good morning, everybody. This is Wednesday of week one, and I'm going to go over a couple of problems like the ones that I posted today. These problems are factoring problems, and they revolve around three different formulas that we've learned in the past, but you might have forgotten, so this is a refresher on how to use those. The first two problems that I'm going to work through have to do with these formulas here. Um, the the left side of this formula is the problem, and the right side is the answer. So we're giving you problems that look like this, and we want you to give us answers that look like this. It's going to be single parentheses squared with either a sum or a difference inside. So let's go ahead and work through one of these problems. Because I'm giving you these formulas, I'm basically telling you that this trinomial is in this form. The way that you can always check to see is if the first term and the last term are perfect squares. If they are, often you'll be able to use these formulas. So x squared is a perfect square, 49 is a perfect square. And that means I can sort of rewrite this equation looking like this right here. A squared plus 2ab plus b squared. But I don't know what a and b are yet. The way you find what a and b are is by taking the square root of your first term and the square root of your last term. That's really the only thing you have to do on these ones, because once you find a and b, you can plug it into your answer. So the square root of my first term is going to be a, and the square root of x squared is just x. So I have a equals x. B is going to be the square root of my last term. The square root of 49 is 7. That means I have a, I have b, and I can substitute it into the first formula. The reason I'm using the first one is because it's plus right here. So this becomes x plus 7 squared. And that's it. That's my answer. Let's do another example here. My first term is a perfect square. 25 is a perfect square. My last term, 16, is a perfect square. So I'm going to go ahead and use my second formula here. The only thing difference is that it's a minus. This is a minus. That's how I know I'm going to use my second formula. So I need to find out what a is. I need to find out what b is. In order to find out what a is, I take the square root of my first term. So I have a equals 5x. Because the square root of 25 is x. The square root of x squared is x. And then I have the square root of 16, which is 4. This is a, this is b. My answer is 5x minus 4 squared. And that's it. So for these problems, it's pretty much the only thing you have to do. I suppose I forgot to mention one thing. You should always check to see if there's a greatest common factor first. These ones did not. Let me go over one that does have a GCF, just so we can be comfortable with that. All right, 6x cubed minus 60x squared plus 150x. All right. So when we're looking for GCF, first of all, you should right away know that there is a greatest common factor in here because there's an x in each term. So let's go through, find the GCF. In order to find the greatest common factor, you need to list all the factors of the smallest number and then check to see if those are also factors of the others. So the factors of 6 are 1 and 6 and 2 and 3. And we check with from biggest to smallest. Is 6 a factor of 60? Yes, it is. Is 6 a factor of 150? Yes, it is. If you're not sure, do 150 divided by 6. If you get a whole number, it's a factor. So my GCF is going to be 6 for the numbers. And then because each term has at least one x, I'm going to factor out an x as well. And then I start dividing out. So 6x cubed divided by 6x is going to end up being 1x squared minus 10x plus what is that, 25? 25. And now that I have that, I can find out what a and b is. So that I can use it in my formula. And you're looking at what's inside this parentheses here. So the square root of x squared is just x. Square root of 25 is 5. That gives me a and b. And I get x minus 5 squared with a 6x in front. A lot of people have been forgetting about that GCF, so please make sure you don't forget about it. If you pull a GCF out, the answer has to have a GCF in it. So this is an example where you factor out the greatest common factor first and then apply the formula where you take the square root of the first term and the last term to get your a and b and then plug it into the formula. Okay, there's two problems that are going to look like that. And there are two problems that are going to have to do with the difference of squares formula, which is something that I've shown you like a million times. A squared minus b squared equals a plus b, a minus b. Doesn't matter what plus or minus comes first. So with this formula, you're basically doing the exact same thing. If you have two terms that are being subtracted, take the square root of your first term to get a, take the square root of your last term to get b. So let me throw up a couple of examples. X squared minus 36, 25x minus 4, and then 9x cubed minus 100x. Okay, so for each of these, you can take the square root of the first term, square root of the last term, after you check for greatest common factor. In here, there's obviously no GCF, there's no x in the last term, and there's just a 1 in the front. So no GCF there. Square root of my first term is my a. Square root of x squared is just x. For my b, square root of 36 is 6. So my factored form is x plus 6, x minus 6. And that's it. All right, second example. Square root of my first term, square root of 25 is 5. Square root of x is x. So my a is going to be 5x. Square root of 4 is 2. That's going to be my b. Sorry for the glare. That gives me 5x plus 2. 5x minus 2. That's my answer. Square root of the first term, square root of the last term, plug it into your formula for a and b. Lastly, for this one, here we do have a greatest common factor, right? Because there's an x over here. So I'm going to factor an x out. There's no factors in common between 9 and 100, so I don't have to worry about the numbers. So I'm going to pull an x out, and I get 9x squared minus 100. And then I can take the square root of my first term for a, take square root of my last term for b. So I have a equals 3x, because the square root of 9 is 3, square root of x squared is x. And for my b, square root of 100 is 10. That means I can rewrite this as x, because my GCF always comes first. Please don't forget that. I'm going to run out of room here. 3x plus 10, 3x minus 10. I actually don't think you have a problem like that in the ones I posted. Just wanted to show you that you can do it with GCF as well. All right, that's it. If you got any questions, hop onto my, whatever those are called. What are those called? Office hours. Hop on my office hours. Have a good one.